Okay, so here's our last video. I don't know how I deleted the title, but this is 20.3, and this section is called density. And you've probably studied density before in your science classes, but it does relate to geometry. So density measures the amount of matter, and it could be that you're measuring mass or population or weight per volume or surface area measurement. So that's how it relates to geometry. So we're going to do two examples today. The first one is going to be what we call population density, and this is an example with respect to area. So this is density and area, if you want to label this little section. And we're going to do one quick example. So for instance, population density refers to the number of people per square mile. So how would you compare New York City to Knoxville to Alaska? And before we even talk about the numbers, hopefully you know New York City has a whole lot of people in it, and it's a pretty small place. So it's what they call very dense in terms of population. Whereas Alaska is a really massive place, but there's not a ton of people that live there, so that's much less dense as far as population. The example here gives us what we need really in terms of how to solve this problem in and of itself. It says people per, and hopefully per to you means division, square mile. So we're just going to divide the number of people by the number of square miles. So I'm going to take my calculator. It says in New York City, I'm going to zoom in so we can see this a little bit better. In New York City, it says there's over 8 million people living in 468 square miles. So in my calculator, I'm going to do that 8 million number, 8,175,000, divided by the number of square miles. And that tells me that in 1 square mile in New York City, which means a block that's like a mile by a mile, that there are, what I've gotten here is that the population density for New York, I don't know why I'm having trouble with this one, is I got 17,449. So I'm going to round. This is people per square mile. That's how you write that, per square mile. All right, so Knoxville, we're going to do the same thing. We're going to divide the number of people by the number of square miles. All right, all of this is division. So take a second with your calculator. You can use your phone and calculate the population densities for those other two. All right, so these are the answers that I've gotten. For Knoxville, I got 1,718 people per square mile. So notice that's New York City has like 10 times the amount of people per square mile that Knoxville does. So if you draw a square mile in New York City, you're going to hit 17,000 people. In Knoxville, you're only going to hit 1,700 people. If you draw that same square in Alaska, you're going to hit one person. One. That means that each person basically has a whole square mile to themselves in Alaska. So when we talk about population density, this shows you that clearly New York City is a lot more heavily populated per square mile than Knoxville, and Knoxville is definitely more populated than Alaska, right? It just talks about how spread out or how condensed people are. Let's look at another example. All right, and this is an example of volume and density. So density can also be used to relate matter to volume. So consider steel versus aluminum, and this is one that I think is particularly interesting because we have the aluminum plant in our backyard. So if we look at this, well, that's not what I meant to do. Consider steel versus aluminum. Steel has a density of 490 pounds per cubic foot. That means if you had a 1 foot by 1 foot by 1 foot box, that's the size of a ruler in every direction, width, length, and height. If you had that box of steel, it would be 490 pounds. Like there's no, well, somebody might be able to lift it, but that's going to be very, very dense. Versus aluminum is 172 pounds per square foot. So that same box filled with aluminum will only be 172 pounds. And I've shown you the picture of this truck here because if you don't know, maybe you do know, Ford has redesigned what they do with trucks, and instead of using steel for the body, which is what a lot of old cars are made out of, is steel. They're really, really heavy. They've used aluminum, and that's because it's lighter. And if you think about driving a car, it would be important for it to be lighter. One, it's just easier to transport, but really the biggest reason is that helps you save on fuel economy. You know, the engine's not having to work as hard to push the car forward because the car's not as heavy. It might be the same size, right? Ford didn't make their trucks smaller. They just made them less dense so that they could get you know, people could get better gas mileage out of their trucks instead of what they were getting with really heavy steel trucks. Maybe the downfall of that is sometimes the aluminum is not as strong as the steel would be. So notice if a really old car gets into a wreck, if they get into a fender bender, that old car usually has no damage on it whatsoever. Might have a little scratch on the paint, versus newer cars, if they get into wrecks, like even just rear-ending somebody, the front end can be totally smashed in because that steel is, or that aluminum is not always as strong. All right, so let's look at the density of another thing here. We're going to calculate what's the density of a 10-pound iron weightlifting plate. So this one is made of, if we're just talking about the difference in elements, this is made of iron. So we're just going to be calculating basically the density of iron. And notice that the other ones, if you zoom up, hopefully you took notes on those, but I'll scroll back to that. Notice that these densities are given in pounds per cubic foot. That means we're going to do pounds, LBS, divided by feet cubed. And we're actually going to do divided by inches cubed just for the sake of simplicity. And we can talk tomorrow about how to convert that if we need to. All right, so that means we need to find, per cubic foot means we need to find the volume. We already know the weight. So I'm going to start by finding the volume of this plate. And we've done a problem similar to this. It was that like donut cake problem. So when I look at this volume, this is going to be, it's kind of hard for you to tell, but this does have a thickness. If you've ever seen a weightlifting plate, it's, you know, it's got like an inch or so thickness. So we're going to calculate the volume, and volume of this is going to be, there's this larger circle, or cylinder rather. I'll draw it out so you can see it's kind of got this thickness. And then there's this cutout in the middle. So that means we're going to do the larger, if it'll let me write, minus the cutout. And this larger, we said, was a cylinder. So that's the area of the base times the height. And remember that base, what shape is that base? All right, hopefully you're saying that's a circle. And circle is pi r squared. So I'm going to do pi times, now if 9 is the diameter, and I know that because it's going all the way across, that means the radius here is 4.5. So I'm going to do 9 times 4.5 squared. And then I'm going to multiply that by the height, which is this thickness, which is 0.9. All right, so I'm going to go ahead and do that in my calculator. Okay, and I did that and I got 57 looks like I'm just going to round to 57.3. All right, now the cutout is also a cylinder, but we're going to be subtracting it. So this time it's still a cylinder, so I'm still going to do pi r squared, but this time the radius, this diameter of the cutout is 2 inches, so the radius is going to be 1 inch. That's pretty easy to work with, times 0.9. All right, we're going to calculate that. All right, when I did that, I got 2.8. Now we're subtracting it because we're cutting it out. We're removing it from the original size of the plate. This is going to give me a volume in the end, and we're going to add units to this. The total volume of the plate is going to be equal to 54.5, and this is in inches cubed. All right. All right, and real quick, I'm going to go ahead and actually show you how to convert that into feet, just so we can compare it to the steel and the aluminum from above. In a foot, there are 12 inches in 1 foot. So to convert this, we're going to divide by 12, and not just divide by 12, we're going to divide by 12 to the third, because this is inches to the third, so we need to divide by all of that. It's going to give us a pretty small number. All right, and the final answer I got then is that the volume of the plate is 0.032, and I'm rounding again. This time we've converted it to feet cubed. So when we go to find density, remember we said density was pounds per cubic foot. So I'm going to calculate this as density. They give us the pounds. That's 10 pounds per, which means to divide by the number of feet, 0.032 feet to the third. And if I do that division, I get that the density of iron, because these plates are made of iron, is 312.5 pounds per foot cubed. And just so we can kind of wrap up and so that you get an understanding. So iron then is less dense than steel. That means that if you made this same plate, weight plate out of steel, it would be smaller because it would be more dense. You wouldn't have to make it as big. If you tried to make this same weight plate out of aluminum, it would be massive. You would have to make it twice as large in size just to get the 10 pounds that you needed, which would kind of be crazy if you were weightlifting, right? Like that would be too big for you to use a lot of times. I mean, a 10-pound weight's pretty small, but if you got up there, you know, think about making one weight plate twice as big. Versus if you use steel, you know, you'd be making about a third the size. All right, so there you go. That's what you have for density. Make sure you have your notes. We'll wrap that up tomorrow. Happy last video.